Hello everyone. This is a programming practice session for this week about classification. In this session, we mainly look at some of the classification examples with various learning methods. Okay, then let's move to the R programming. Alright, in this programming practice, we're gonna use Iris dataset. You can download it from the course webpage. So in order to read the dataset, I believe you already know how to read the data. So let's store the read data at the variable data, and we're gonna use read table functions, and the name of the file is kmove of 04 and dataset iris. And again, because it has the column name at the first row, so we use header is as a true. All right. Then let's check the data. Okay, in total we have the 100 samples and it has the 5 columns. Then let's see what is the data. Let's see the first 10 rows. Um, so it has the 4 numeric data variable and 1 factor variable, discrete variable. This is species. So let's see how many species. Table data color and species. Then there's two types of the iris. One is verticolor, the other is the virginica. So in this example, we're gonna classify this the species of this iris based on their the sepal length and width and petal length and petal width. And based on this the 4 numeric data, then we're gonna classify whether the corresponding iris is the versicolor or Virginia. Okay, so in order to again, because this is another prediction problem, so we need to make the train set and test set. Then let's use the first. Okay, let's use the 60% as a training set and leftover of the 40% as a test set. So here, train index, we can set train index is C1 to 30. This is a training set for the vertical, and 51 to 80. This is a training set for the Virginica. All right. Then data of the train is data and indexed by this train index. All right. Then data of the train is, and it's 60 samples. So 60 samples is our training set. Then test set, data of test. So here, interesting, the interface of R is we can index minus numbers, train index. So in this case, minus means so all other index except this the negative ones. So by putting the minus train index, then we can select all other rows beside this training index. So then we can make the separate or exclusive train data. And click check the data of test. Then it has the 40, right? Then we have finally we have the training set and data. Okay, so throughout this example, so we're gonna use the logistic regression and also LDA and SVM. First, let's try the simple logistic regression first. Okay, logistic regression can be done by this GLM function. GLM is the generalized linear model. Okay, so this is the GLM function has a very powerful providing the very powerful the modeling the linear models. So it's So the use of GLM is quite complicated. But in this case, let's only focus on the logistic regression. So the performing this logistic regression with this GLM is like this. First, we need to define the space. First, we set formula. So here we want to regress this species with. Okay, let's first do the simple linear regression with only one variable, and let's say that variable is a petal width. Okay? So this is our sample, our formula for the regression. And here, then what kind of the linear model we want to use? That is defined by family. And in this family, our family is defined by binomial. And among this binomial, especially we want, so it is specified, the link logic. So this is the form of the logistic regression. Okay. Then definitely we need to set the data. What kind of data we're gonna use? That data is data.train. Okay. So let's save this repeated model at f as simple linear simple the regression simple logistic model. Okay, here it's like that. All right, so if we see like this, so it is looks like this. So we have the coefficient. Definitely, this is the coefficient of the the logistic regression model. All right. Anyway, so here, then how can how can you obtain the the fitted value? And similarly, if you record the previous um, the programming practice, in many cases we can use just use predict. So this y is the predicted one. Predict, just use predict. Then we use the s fitted model FSLG, simple logistic regression. Then the the new data is data.train. Then that means we're gonna provide the x in the training set, which means the predicted y is the fitted value of this mm, based on the x of training set. Then here we're gonna use the type as a response. So there are certain options about this type, but here we're gonna use the response. Then if we see y is just numbers, usually between 0 and 1. So here y is just the probability to be equal to 1. So in this case, the 1 is it's two classes. So one class is 0, the other class is coded as 1. So this is actually a probability that the given sample is classified to the certain class, class 2, let's say class 2, or the class 1. If we have the class 0 and class 1, this is a probability that this sample is classified to the class 1. Okay. So in this case, the class 1 is I guess the class 1 is the Virginica, and the class 0 is the versicolor. Okay. So here, then let's plot this is the observed value and this is the fitted value together. So first, let's plot data.train of the petal width and data.train of species, whether species is equal to the Virginica. Okay. If we plot this one, so if the sample species is the versicolor, they have a 0 value on y. And if it's the Virginica, it has a value 1 on the y. Okay, then x-axis is the petal width. Okay, so here if we line up, okay, in order to to make a line, we first make an order of the of the x value width. Okay, then we make a lines that train at petal width. Then this one data that train dollar and petal that width this and with indexed by this O is the ordered one. That is the how can I say that? That is sorted value. Here we also to put the same sorted one with the y. Y is O, and let's say color is 2 and the width is 2. Then okay, here we're gonna see this is the actually the S shape or the sigmoid function that starts from 0 and it reaches to 1. So this is typical curve in the um, in this the logistic regression. Okay, so it is good. It is good. Okay, so it's good. But this y function, this predicted y, this y is just number. But actually, what you want to do is we want to make the class, assign the class. Then how can you assign the class? So because this is a probability, if this probability is less than 0.5, we can say, okay, this is a class of versicolor. So if it's the probability is more than 0.5, then we say this is the Virginica. So we can actually make this train of the actually fitted or the predicted value predicted y can be we can encode as a factor by using whether y is by determining whether the y is less than 0.5 or not. So if it's true, then it has the numeric value of 1, then it has the Virginica. Okay, so then this one y is whether the larger than 0.5 or not. It has two levels. The levels are false and true. Then each false and true, we want them have two the labels. One is Versicolor, and the other is Virginica, right? Versicolor and Virginica. Okay, and if we the train SGL, then it is encoded. If this y value is more than 0.5, then it has the Virginica. If it's less than 0.5, then it has the Versicolor. So we can use this factor, then we can encode it. Okay, so similarly, we can predict. Okay, so similarly, we can predict using the test set. This is the real prediction. Okay, and similarly, we can actually encode it. Alright, then we have the predicted value like this. Then let's check it. Let's check how it is, how much it is the exact. So let's check its accuracy. So the easy way to check it is using the table. So using table, let's say trained by SLG. This is a prediction of the training set. Then let's compare it with the actual truths per species. And here, okay, so you can see here, these rows are each rows are what predicted, and columns are actual truth value. So among in total 30 true versicolor, our prediction actually predict in a correct way for 23 samples, but 7 are missed. Here 8 is error and 22 is so the right answer. So this is for the training set. How about the test set? Okay, so in the test set, it's similar. Okay, so this is a table. So here we want to actually make some okay, so here we want to make the quantitative the error rate. Then if we so here we can calculate that quantitative error. Okay, let's calculate the quantitative error of the error train. This is just a mean that y dot train dot slg is not equal to data dot train the true value. Okay, this is the error. Then error is 25%. Okay, then how about the test? Or the test error? It's more than 25%. So this is the error rate. Okay, so this is our prediction performance. Definitely, this prediction performance is quite low because we only use one variable. Definitely, here we can use the more variables by using the general or multivariate logistic regression. Okay, so then the leftovers are simple. So if we want to use the multivariate logistic regression, we can use such models like this. So let's copy and paste it. Okay, so if you look at this one, so we use the GLM, then we regress species with that. This that means within this data set, we're gonna use every other variables to fit this species, and this part is actually indicator the logistic regression. All right, then we have the multivariate and the others. So this code is a part to predict, making a prediction for the Y train and the Y test. Then this is a part of the calculating errors. And this is the table code. So if we just copy and paste everything, then if we see the table, then if you compare this one with the previous one, we can see the test train data set is reduced, but I don't know about this one. So, but we can definitely check it with this the error train logistic regression. Oh, it is reduced compared to the simple logistic regression. How about test? Well, test is increased. Okay, so that is currently what we have. Then next move to the LDA. So LDA is not provided by default. So instead it is part of the MASS library, MASS. So here we use the MASS include library MASS. Okay. Then the LDA can be fitted by this LDA function. So using LDA, and this is the formula, and everything is very simple. The formula, then data equal to data. So it is very similar to use the linear model LM functions. Okay? So it is very simple. Good thing of the LDA is it's a result of the predict function. So the use of the predict function is also easy. So here we put as a first argument, we put the fitted model. Then second argument is actual data we want to use. Okay. Then good thing of this one, then good thing of this prediction is it returns class itself. So okay, so there's a lot of stuff, but class, they have another class like this. So we don't have to do some complicated things as like this the logistic regression. So then then every the others are the same. So we just use we calculate the error and we make the tables. Okay, so let's copy and paste. All right. So their table looks like this. Okay. Then next is SVM. SVM is actually the package that belongs to the package of the E1071. Okay, I don't know. So actually, I don't know, what this code what is the weird name actually means. However, so SVM anyway, SVM is a part of this library, and this library does not included by the is not included by default in R. So we need to install it from the from the internet. So if you want to do, please use this install package command. And if you want to install it, then we can use the call it library. Then the others are the same. So we can use the SVM. Then it's a formula. Also, then it's the data. Technically, if you call the help SVM like this, here there's a lot of the options, and some of the options, one of the important options, this is a kernel, but by default we're gonna use the radial kernel, and this is degree 3. So when we use the polynomial kernel, and here is the gamma factor. So there's a lot of options, but at this moment, so we're gonna use the default value. So then same. So prediction, the use of the prediction is the same, and this is a calculation of error, and this is a table. Okay, so let's copy it. And it's the result is like this. Okay, so finally, let's summarize it. So up to now, using the simple linear logistic regression and multivariate logistic regression and LDA and SVM, using these 4 different methods, we calculate the prediction accuracy or error in the training set and the test set. Then we already calculate all of the error rates. Then we're gonna make it as the one big matrix ERR using such the matrix command ERR. Then ERR looks like this. And so then because this is just a matrix, so if we want to look at it more easily, then we're gonna make the column name and row names. Then ERR so first column is for the simple logistic regression, and first row is for the training error. Then second row is test error. Then if we plot it, it is like this. Okay. So as you see here, if you compare it, SVM has the best performance in both training and test set. Okay. So if you compare the simple logistic regression and the multivariate logistic regression, in the training set, you have the lower error rate, but in the test set, it has a higher error rate. This is because of the overfitting, I guess. But you're gonna see, how you can actually, manage this overfitting in the next session. Okay, so this is the end of this example, and I'm gonna stop this session here. All right, thank you very much.